Chapter 1-4 continued. Solving for an indicated variable. All right, today what you're going to need is you're going to need a highlighter. And it's not necessary that you have one, but it's very helpful if you have one. It's going to help you keep your thoughts organized. So here we go. Now, if I give you something like this, the first thing I'm going to ask you to do is to go ahead and solve this for a specified variable. Now, I took these problems directly out of your textbook. And again, this is from section 1-4. And if you have your book open to page 31, this is problem 33. This is the solve for h. So what I need to do is I need to isolate h. So I need to get rid of the first thing that you think that's ugly. The first thing I think that's ugly here is that value of 1/2. So how do I get rid of that half? Well, it's attached by multiplication, so I would divide. But when you divide by a fraction, you are actually multiplying by the reciprocal. The reciprocal of 1/2 is 2. So I'm going to multiply both sides by 2. So I have 2 capital A is equal to, the 2's cancel out, BH. Now again, what am I solving for? I'm solving for h, and what's attached to h is the letter b. How's it attached? By multiplication, so to get rid of it, I divide both sides by b. So I have 2a divided by b is equal to h. Done. Let's do it again. 37. 37 in your textbook says to solve for x. Now, the difference between this one and the last property, or the last example, was I have 2 x's here. Since I have 2 x's, what we need to do is we need to combine the like terms. Or another way to look at this is to pull out a GCF. GCF is the largest number or variables that 2 or more terms have in common. Now what I mean whenever I talk about this is I'm going to refer to this as going fishing. Yes, it sounds hickish, but that's what we're going to do. We're going to fish out what is in common with each one of these terms. So if I fish out an x out of this first term, I pull out an x and I'm left with an a here. If I pull out an x here, I'm left with a b. When you pull out a GCF, what you're essentially doing is pulling out what's in common between the two things, which means it's the opposite of the distributive property. So if you were to distribute this, would you get the original problem? And the answer to that is yes, you would. So now that I've pulled out what's in common, which is the x, I need to continue to solve for x. So what's attached to the x? What's attached to the a plus b, the whole quantity. So what we're going to do is divide by that whole quantity of a plus b. So the a plus b is gone on both of them, and I'm left with x is equal to c over a plus b. Now, backing up backwards, you're going backwards. I have h. There was only one h, so I didn't pull out a GCF. Looking at this one, there's 2 x's. So I needed to get my x's on the same side, which they already were. And then I went fishing, and I pulled out what was in common, which was the x, and I was left with the chunk of a plus b attached to it, and that's why I divided by it. So 38. 38 in your textbook says to solve for x again. So if I'm solving for x, again, I'm going to highlight what I'm solving for, so I can keep on track. And do I get rid of the a first, or do I get rid of the 5 first? Well, if you remember, whenever we solve equations, you work PEMDAS backwards. So I need to get rid of what's attached by addition or subtraction first. So I need to add 5 to both sides. So working from left to right, I bring down the x over a is equal to b plus 5. Now I'm solving for what again? X. Highlight that x so you can visibly see it. Now what's attached to the x is the a. It's attached by division, so how do I get rid of that? Multiply. So I'm going to multiply both sides by a. Putting that in parentheses and putting that in a there. This cancels out, and I'm left with x is equal to a times b plus 5. I accept that. Or how many of you are itching to distribute? If you want to distribute, then go ahead. That gives you x is equal to ab plus 5a. I would accept either or. Okay? 39. Again, we're solving for x. Here's my x. Now remember whenever we talked about solving equations previously, I said that the numerator is a problem and I said that the denominator is a problem. Now here's what we're going to do. We're going to make things really, really simple. We're going to put this whole thing over 1. And what we have here is a fraction equaling a fraction. And do you remember whenever we were solving equations previously, what did I tell you when you had a fraction equaling a fraction? I told you to, if you said cross multiply, you're correct. So I'm going to have 1 times x minus 2 is equal to 2 times an m plus an n. Distribute. X minus 2 is equal to 2m plus 2n. And what am I solving for, folks? Well, I'm still solving for x. Now I need to get x by itself. So how do I get rid of that 2? I add 2 to both sides. Notice how I'm lining up my terms. I bring down x, 2m is by itself, 2n is by itself, and I put that 2 clear to the right because I knew there was not a like term to it. And it's solved. Okay? 40. 40 in your textbook, again, says to go ahead and to solve each equation. Now, I want to solve this for the equation of x. I want to solve this thing for x. So what I need to do is I need to isolate this thing. Well, what did I do before? I had some ugly junk going on here, so I need to get rid of that ugly junk. So what do I get rid of? Well, we've been getting rid of fractions. Wouldn't it make sense to get rid of that 5? Sure, so we're going to multiply the entire thing by 5. So when I do that, the 5's cancel out, and I'm left with 2. Bring down the junk. Is equal to, go to the other side, and that gives me a 5g. Now what am I solving for? Solving for x. Well, what's attached to that x? If you wanted to, you could distribute, or you could simply divide. I'm going to go ahead, and I'm going to copy this. I'm going to do this both ways for you so that you can see what I'm talking about. I'm going to divide both sides by 2. That cancels out, and I'm left with x plus 1 is equal to 5 over 2 g. Subtract the 1. And x is equal to 5 over 2 g minus 1. That's one way of doing it. Another way is to distribute 2x plus 2 is equal to 5g. Subtract the 2. 2x is equal to 5g minus 2. And divide each term by 2. X is equal to 5 over 2g minus 1. Same exact answer, correct? And I did it 2 different methods. Doesn't matter, whichever method you feel is more appropriate for you, please go ahead and use. Okay, 55 out of your textbook. Again, it says solve each equation for x. Where's x at? I have an x here, and I have an x here. So I have 2 x's, and they're inside parentheses. What do you think instinctively we need to do? If you said distribute and get them out of parentheses, you are correct. So what we're going to do is we're going to distribute, keeping them in alphabetical order. Cx plus 2c minus 5 is equal to bx minus 3b. Okay, now we're still solving for x. I have x's on opposite sides, so I need to get my x's on the same side. So I'm going to bring over this bx from both sides. So I have cx minus bx plus 2c minus 5 is equal to negative 3b. Now, what am I solving for? I'm solving for x. I have 2 x's there. Before we can go fishing, which is an instinct that you're wanting to do, I need to isolate it, and I need to take everything that's not an x over to the other side. So how do I get rid of this plus 2c? Well, to get rid of it, I subtract 2c. How do I get rid of this minus 5? I'm going to add 5. So I'm going to subtract 2c and add 5 to both sides. From left to right, I drop down my cx minus bx. The 2 c's are gone. and the 5's are gone, and that's going to equal negative 3b minus 2c plus 5. It looks really ugly, but again, just follow step by step. So now I have just x's on this side, and I have two of them. Well, remember in the second example I did, we went ahead and we pulled out what was in common. But what's in common here, which is my GCF, is the letter x. So if I fish that x out, I pull out an x, I'm going to be left with a c minus a b is equal to 3b minus 2c plus 5. What am I solving for? I'm solving for x, so what's attached to the x is going to be the multiplication of c minus b. So I'm going to get rid of that by dividing by that. And x is equal to negative 3b minus 2c plus 5 all over c minus b. That was a sticky one. That was a sticky one. Okay. Let's go to the next one. 56 is very similar, and again, it's nasty and ugly. So let's go ahead and try it. I'm going to be solving for which letter here? X. Well, I have an x here in parentheses, and I have an x here in parentheses. But what did we do with the last example? The last example is we distributed. So keeping my terms in alpha order, 3atx minus 2ab is equal to cdx minus 2c. Again, what did we do last example? We got our x's on the same side of the equal sign. So I'm going to bring over this cdx by subtracting it. So I have 3atx minus cdx minus 2ab, this is gone, is equal to negative 2c. Now we want to isolate just this, because those have my x's in them. So I need to get rid of that 2ab. So it's attached by subtraction. So I'm going to add 2ab to both sides. So from left to right, what am I left with? Is this junk with my x's in it. The 2ab's cancel out, and that's equal to negative 2c plus 2ab. Now, this is the part where we are left with just my x's, and I ask myself, what's in common between these two terms? And what's in common, because this is what we did on purpose, is we left the x's on the same side. So I'm going to pull out what's in common, which is going to be the letter x. When I pull that letter x out of my first term, I'm left with 3at minus, if I pull out an x out of my second term, I'm left with a c. And that's going to equal 2c at 2c plus 2ab. Ask yourself the question, what am I solving for? I'm solving for x, so what's attached to it? Well, that ugly junk's attached to it, that parenthesis by multiplication. So to get rid of multiplication, I divide. So I'm going to divide by the ugly quantity here. Okay, these cancel out, and I'm left with x is equal to negative 2c plus 2ab all over 3at minus cd. Okay. Now, we're going to start off your worksheet with you. I'm skipping two of those because I want to make sure you guys are understanding what we're doing now. So let's start off small here. And let's do 3ar minus b is equal to 6b. And we're solving for r. There's only one r in there. Since there's only one r in there, I need to get rid of that doing PEMDAS backwards. So what's attached by the subtraction to b? So I'm going to add b to both sides. I line up my b's on both sides. 3ar, those b's cancel out. 6 bananas plus 1 banana gives me 7 bananas. Again, what am I solving for? I'm solving for r. So how do I get rid of that 3a? I get rid of that by dividing by 3a. So 3a's cancel out, and I'm left with r is equal to 7b over 3a. Okay. So another one, solve for b. Number 5 on your worksheet. I have two b's. So in order to get rid of my v's, they're on the same side, but I need to do what? Go fishing. So if I go fish, I'm going to fish out what's in common, which is going to be the letter v. If I pull out of v out of the first term, I'm left with 5r minus an s is equal to 2r. Again, I'm solving for v. So I need to get rid of the 5r minus s. It's attached by multiplication, so I'm going to divide by 5r minus s. Those go away, and I have v is equal to 2r over 5r minus s. Okay, that's all I have for today. We will work on this in class tomorrow.